want to sit still anymore. You want to run around. You'd fill up all this space. There would be the same amount of you, be the same mass of you, but you'd be taking up more space. So you become less dense. And we know that if something is less dense than something else, it will float. And if I give some molecules some Red Bull and some caffeine, all I need to do, instead of giving them Red Bull and caffeine, all I need to do is heat them up. So I've heated up some water in this kettle, and what I want to show you is that water floats on water. In hot water, I'm saying molecules are moving around, they're taking up more space, so they're less dense than the cold water, which is sitting in this glass here. Okay? So, I'm going to colour the hot water red so you can see it. That should be enough for our purposes. And what we need to do is just show you that this glass of water, and the water in this glass, will float on the water in that glass. Fill these up. So you can see the red water is the water that's come out of the kettle, the hot water, and the water that's sitting here is cold water. It's just the same temperature as the room, what we call room temperature. So what I have to do, take this glass, turn it over, put it on that glass. Now of course, you do have to practice for many years to be able to get this right. And the first time I did it, I made such a mess that we're still cleaning bread off the kitchen sink. So I'm going to cheat. You know what these are? CDs. I have to ask, because you have downloads, streaming, thumb drives, goodness knows what, you may not have had to use one of these. Two of these have got a hole in the middle, yeah? Put those together, I can put my finger through that hole, yeah? See the hole, put my finger through it? Yeah, good. Yeah, you can still see that hole with my finger through it? Yeah? Okay. If I slide them apart like that, the holes are closed up just enough so that I can put one on there without spilling too much. And then I slide the CDs together, those holes line up, and the hot water is floating on the cold water. Now, some of you I know are saying, but that would have happened anyway. And that's what a scientist would say. Scientists would say, well, that wasn't a very big hole. We might expect that to happen. So, what we're going to do is do that the other way around. So put the cold water on the hot water. Now you can see perhaps the hot water is floating upwards. Cold water must be going somewhere, so that's sinking downwards. So you can see the hot water rising into the upper glass. Leave these for a while. These two glasses will be the same color. And these two glasses will have the colours water at the bottom and the red water at the top. Now, some of you may know the Olympic Games is going on right now. Yeah? Olympic Games? Well, if you're a high-level athlete, you have to submit your blood and your urine to check that you're not using drugs. And it's a chemist that sorts out what's in that mixture, whether there are markers that show that you are using things that you shouldn't. And one of the easiest chemical tests we can do is a colour change. So here I've made some tea. This is a tea bag. It's giving me this colour. If I put my tea in there, you can see, I hope, that it's coloured. Yeah? The answer is yes, all right? You can see that it's coloured. Yes? Yes, good. Now, did anyone clean their teeth with toothpaste this morning? Yes, good. Now, toothpaste has a base in it. We use a lot of bases for cleaning. And why we use a base in a toothpaste is because a base will counteract an acid. And in our mouths, we have bacteria. They eat food that's left over in our mouths, and they produce acids. And those acids destroy our teeth. So, I have a base here. This isn't toothpaste. This base is something called soda ash. If you're lucky enough to have a swimming pool, I don't, if I were lucky enough to have a swimming pool, I would use this to make sure you have the right acidity level. So I've got that dissolved here, and what I'm going to do is add it to my tea. And you'll see that the tea has changed colour. What this now is telling me that this mixture is a base. Now, I said that a base and an acid can counteract one another, so an acid can use up all that base. Now, I have an acid here. This is an acid you may well know. It's vinegar. So, I add some vinegar. So these things we call indicators. Called indicators because they're indicating to us, they're showing us, they're indicating what's in a mixture. And this is an acid-base indicator, but you can have all sorts of other indicators that can show you whether something is present or not in a mixture. Now, I don't know about you, if you've ever had to stand up and talk for a while, you might have a drink halfway through. And I brought a bottle of water, but you can see someone has stuck sticks through my water bottle. I think I know who it was. But now, I'm going to ask you to be scientists and make predictions. I'm going to take those sticks out. Is the water going to stay in the bottle, or is it going to come out of the hole? Who says? Hands up, stay in the bottle. Hands up, come out of the hole. Hands up, I haven't put my hand up yet. Very honest of you, sir. Okay, so the safety comes with your own head, make your prediction. It's either going to come out of the holes, or it stays in the bottle. Now, I'm going to put my fingers over those two holes so it doesn't come out too soon, and what do we see? This works because we live at the bottom of the sea. Our sea is made up of air. And just like at the bottom of the ocean, where there's lots of water pressing down at the bottom of the ocean, there's lots of air pressing down on us. And so that air is pressing in on those holes, the moment, everything is in balance. So the pressure pushing in is the same as the pressure pushing out. But if I loosen the lid, I'll let the air pressure from outside in, and then we'll see the water Now, chemists have to know how to put things together. They have to know how to make new materials. They have to know how to make the drugs that go into our medicines that we take when the doctor gives us something to take for an illness. But the chemist also needs to know how to take stuff apart. And so I've got some bicarbonate of soda here. What minute? 10. 10! Oh, 12 minutes after. Anyway, I've got some bicarbonate of soda here. Now, the clue is in the name. If something is called a carbonate, maybe a bicarbonate or just a carbonate, it has that in its chemical name, then if you add an acid, it will give off carbon dioxide. So, I have my solid, which is my bicarbonate of soda. And I'm going to add a liquid acid, which is my fuel. What should I see? What should we observe when we do that? So what is carbon dioxide? Is it a solid, a liquid, or a gas? Solid. I'll give you a clue. We breathe out carbon dioxide when we breathe out air. We breathe in air, and part of the air that we breathe out is carbon dioxide. Is that a solid? Is it a liquid? Is it a gas? Yes, carbon dioxide is a gas. So I've got a solid in here. I'm going to add a liquid acid. And I'm going to produce a gas. What should I see? What are we going to see when I do that? Okay, let me give you a clue. If you're in water, you might be in the bath, you might be swimming somewhere. You're a solid, right? You're in a liquid, and you make a gas. What do you see? Bubbles. That's what we're going to see, bubbles. So here's my solid, and I add my liquid acid. There. You see it fizzing up, and those are bubbles. Now, but I said to you, they are bubbles of carbon dioxide. So what I want to try to do is show you that they are bubbles of carbon dioxide. Now, please don't tell any of your teachers that I'm lighting fires in school, because they'll never allow me that. Now, what I'm going to do is pour myself a glass of carbon dioxide. Now, of course, I don't know whether there's any in there, because carbon dioxide is colorless. But let's see what happens when I do this. Denser than air. Remember we talked about density earlier? Carbon dioxide is denser than air. So when I produce the carbon dioxide here, the air floats on top of it and floats out of this container. Just like this over here. Now the hot water is floating on the cold water. So the air floats on our carbon dioxide. Then when I pour the carbon dioxide into this glass, just like the cold water in the other one, it settles to the bottom, fills up the glass and the air floats out. And then when I do it here, the carbon dioxide settles to the bottom again, and And when it reaches the candle has no more oxygen, and when it has no more oxygen to breathe, it goes out. So, another fuel that I have, that candle there, the wax in the candle acts as a fuel. Another fuel I have here, this is, where is it? It's methylated spirits. And I'm going to show you, I hope, how we drive our cars along the road. So, I'm going to have to take, now this is taking the place of the petrol that you would pour into your car, and then what we need to do is mix that liquid. Well, we need to evaporate the liquid. We need to turn the liquid into gas. So I'm going to use a toaster here to warm up the bottle. That we need to turn that liquid into a gas and mix the gas with the air in the bottle, so there's oxygen for it to breathe and burn in, and then you'll see what happens. So this is what happens in your car. In your car, there's a magic device that's not magic really, but there's a device which mixes the gas that you make out of the liquid petrol with air, and then that is what burns in the car. Now, I'm going to tip away the liquid. You don't want the liquid because the liquid doesn't burn. Liquids don't burn. It's the gas that you form from the liquids that burn. We'll get rid of those. Make my bottle just a little warmer. Then we should be ready to go. Now this you're going to have to watch very closely, because this is sometimes it's hard to see what's going on. So remember, watch closely. We don't drink petrol to power us, we eat food. So, I'm going to try to show you how much energy there is in some food. I'm choosing maizena for this. So, if we take some maizena, what I'm going to try to show you is how much energy is in the maizena. That is going on in your bodies right now. Maybe not a big flame like that, but you eat food, you breathe air with oxygen in it, your body takes the oxygen, puts it together with the fuel, the food, and that produces carbon dioxide, which we breathe out.